So you want to learn about what is a MAC address or what are MAC addresses? You have come to the right place, my friend. I'm going to explain you what it is, what they're used for, in a very simple way, in a very light way, so you can understand the reasons for them to exist and why they do exist. A little bit of context first. So I'm pretty sure you guys and girls have something like this. This is a Raspberry Pi computer. So this is a computer. It's a small form factor computer that you can buy. Well, nowadays they are very expensive, to be honest. But why am I showing you this? Because this guy here has an Ethernet port. So let's put it to the light here. So you see here, it has an Ethernet port there. It's focusing on my face because that's how I am. Okay. And it also has a Wi-Fi card, a wireless card. But maybe you have something more similar to this, which is a standard desktop computer. So this is a desktop computer, simple, pretty standard one. And this one also has a Wi-Fi antenna, like you can see there pretty clearly. And it has also an Ethernet port right about there. See? So the Raspberry Pi and desktop computers have usually, and laptops too, but I don't have a laptop here handy, have the Ethernet port and the Wi-Fi card to give you network connectivity. Usually we talk about, or people say, it's for internet access. Yeah, it can be used to access the internet, but it can be used to access any resource on your local network, either being rather big or rather small. It's still a network. Even if it's wireless or networked with a cable. So these two devices will allow you to access resources on your local network. Access the internet, yes, that's one type of resource, but also printers, file servers, other computers, whatever the case. So if you have a local network and you need those computers to communicate with one another, you need either a wireless card or a networked card. So usually networked offers better performance, generally speaking, but let's leave that for another conversation, another video. Today we are here to learn how they can communicate on the local network, and what is the use for MAC addresses on that context. So let me show you here this. So I'm going to draw a schematic here so you guys can understand a little bit more about what I mean by local connectivity and local resources. So let's just switch to my whiteboard here for a second, and I'm going to draw a couple of things for you. So here I have already represented a computer. So this is a PC. I will represent a second PC. I'm going to put 2 for simplicity's sake, but you can put 200, 2000. This idea can expand really fast, really quickly, but that's again for another video. Let's keep this really simple. You have 2 devices, for example, my Raspberry Pi and my PC, my desktop PC, whatever the case, and usually they are connected to some sort of local device. In the old days, we used the hubs. Now we use the switches. Okay. Again, these are 2 pieces of technology that I will discuss on a later video. Make sure to like and subscribe to get updated on new content about that. But right now, let's just understand this. This is kind of a simple network between 2 PCs and a central location where all the PCs are connected to. Usually you use a hub or a switch. Again, I will discuss it in later video, differences between one and the other, and if there is a better one against the other. So again, going back to the initial theme of our video. So as you saw beforehand, I showed the Raspberry Pi and a desktop computer. They both have a network card. Well, 2 to be realistic, the Wi-Fi one and the one with the cable. I will focus on the cabled one, but Wi-Fi it's similar, even though there are some slight differences, but that's for another video too. So let's say you connect network card with the cable between the PC and the switch, and you have a local connection here, okay? So they are connected to a central location that will be responsible for the distribution of the information. That's all great, that's all fine. But like in our household, so for example, you are on a household, in your home, with your family, so you need to use names to identify people on your home. And often those names are only relevant locally. What I mean by that is maybe you have some sort of nickname, honey, lover, something like that, to identify your spouse, your husband, whatever the case. And those names are only relevant locally. So if you go outside and call someone by that name, by that nickname, maybe they will want to respond because that's only relevant for your household, your local network, right? MAC addresses are something of that sort. It's a number. I will discuss the format in a second. Just wait a minute. In this context are numbers. That has 48 bits, but that's just for another conversation. Just remember that name. It's 48-bit. That's fine. And those names are used to identify devices on your network. Okay, so you have PCA, PCS, if it's I don't know, PCA, PCB, for example, and they need to know. They need to have a way to identify each other on the network. And that's where the MAC addresses come into play. Some of you probably are thinking about, what about the IP address? Yes, that's something we need to discuss later on a later video. But the IP address is slightly different. While the MAC addresses are used to identify devices, I'm saying PCs, but you can say PCs, printers, whatever has a MAC address that can be connected to a central location like the hub or the switch, can use those MAC addresses to identify each PC, because as you can see, this is kind of a piece of a much bigger picture. But I hopefully in the end, with all the multiple videos, I can draw all the pictures slowly and with simple examples. So you have a local network with your switch, and you have host A and host B, and each host has its IP address. I'm sorry, its MAC address in this case. MAC address, not IP, MAC address. MAC address, okay? So this MAC address is used to identify the device on its local network. It's a number. It's a 48-bit number, but this number, it's only relevant to the local network, to this network itself. Okay. To give you a very, very simple example, if you are a little bit more advanced at this point, it's only relevant on your VLAN. As soon as you reach a router, if you have a router somewhere in the network, and if traffic by some reason reaches the routers are responsible for blocking this MAC address information. Okay, so it means that, for example, I'm sitting here in my studio. If I want to know the MAC address of a machine on Google's data center, for example, I will be just impossible to find that out. Okay, so MAC addresses are only relevant on our local network. IP addresses are more global. Okay, IP addresses are more global. Yes, MAC addresses are completely local to our network. They are only relevant on our VLAN or only relevant on our bus or star. I will talk about bus and star topologies on a different video, okay? But that's just for you guys to get some context, and maybe you are a little bit more advanced and you understand these concepts. But again, going back to the initial conversation, MAC addresses are only relevant on our local network. Okay, they are not able to traverse to other networks. Okay, so this is what a MAC address is. So the MAC address is used to identify hosts on our local network. Okay, and again, just to make things even clearer, MAC addresses are only used while using Ethernet, the Ethernet standard, which is the ones I showed you in the Raspberry Pi and on the PC. the Ethernet standard, and also on Wi-Fi. But let's focus on Ethernet for the time being. So we have Ethernet cards connected. So Ethernet. So Ethernet, it's just a network standard, okay? So Ethernet, it's a standard that was developed many ages ago, but still applies with some changes and some updates, of course. But that still applies, okay? So Ethernet is a standard that enables PCs to communicate through cables on the local network. And so they can communicate with one another. They use MAC addresses. I have a very simple MAC address here, and I have a very simple MAC address here, okay? The MAC addresses do not look like that. I will show you some examples of real MAC addresses in a way. But the MAC addresses are used so that computers can communicate within the local network, okay? They have a specific format. So if I pulled here in a very, very simple example, which is They have 48 bits. That's a given, and they are usually divided into sections. Okay. They have a section called OUI, Organization Unit Identifier, and have a second section called NIC, Network Interface Card. So the whole of this then creates the full MAC address. You don't have to worry too much about how MAC addresses are managed by the computers, because they will do this for you. Okay, so the MAC addresses will be managed by computers themselves. MAC addresses are burned in on the network card. So you have your Wi-Fi card, you have your Ethernet card. The MAC addresses that are used to identify computers within our network, and that's pretty much self-managed by the PCs. The MAC addresses are burned into the network cards. You don't have to configure them yourself. You don't have to go to some configurations settings. They are just there. They are just built in or burned in by the manufacturer. That's why you have the OUI. So the manufacturer, when creates the MAC address for you for your NIC, it will identify the vendor, the manufacturer. Realtek, for example, it's a very common one. So Realtek will put his OUI on its first 3 bytes. It's 48 bits, 3 bytes. Don't worry too much about bytes and bits and the math. That doesn't really matter. In simple terms, the first 3 segments of the number, which are 6, as you can see, 3 yellow, 3 blue. The first segment here, the first half of the address, if you can call it like that, it's the OUI, Organization Unit Identifier. And with this number, we can identify who was the manufacturer of this card. The second part, it's the NIC. So this is unique to the PC itself. So the group of these numbers that are burned in by the manufacturer. So the manufacturer, when he builds the network card, either being on the motherboard, either being the one you buy separately, it's built in, it's burned in. You don't have to worry about configuring this. This is configured by the manufacturer from factory. Okay? So this is already built in, but this is useful in a way because this is unique. Okay? So it means that if I look at a specific MAC address, I can know who was the manufacturer of that network card. Okay? Let me show you an example. I'm going to show you how it's done. So if I go to my Windows machine, I can just type. Let me just clear the screen because it's a bit easier. So if I do ipconfig/all, so I'm using here a very old. This is Windows XP because don't worry too much about it. On our normal Windows, or not normal, on more modern Windows, it's the same thing. You do ipconfig/all. And you can see your MAC address here, okay? If you have multiple cards, you will see multiple MAC addresses, which is fine. So you have your MAC address here, like the format I just shown you in the previous example, okay? But this one is a real MAC address, okay? So I'm just going to copy this. I'm going to get this number, and I'm going back here, and I'm going to show you a website that you can just Google for this. Just Google for, this is called OUI lookup, but you can just Google for whatever the case. You can just Google for example, OUI Finder or MAC address vendor finder. They all come to the same location because all these MAC addresses and all these IDs are registered, so they are not random. So, for example, if Cisco needs to build, well, it does, of course. It's when Cisco builds a network card, he needs to register those numbers. So this is kind of publicly known and registered. It's unique. So let's type here let me see if I could copy this. Okay, let's do 000C29. And as you can see, it comes out as, I'm sorry for all the pop-ups, man. It comes all as VMware, which is true. This is a virtual machine, which is a virtual machine from VMware. So it actually adds up. As you can see, I typed my MAC address using the dashes. So here you have columns. Either way works. Sometimes it's represented with a column, sometimes it's represented with the dash. Usually, most things will understand both methods, so it's fine. Okay. So if I go back to this situation there, and I can swap to my Linux box here. But I think this will suffice. Yep. And I will type the Linux command to do so. Usually we use the IPA. Okay. If you are a little bit more old school, like I am a little bit more old school, you usually use type ifconfig. So ifconfig or IPA will do the trick. But don't forget that ifconfig, it's considered right now a discontinued command. So try to get your head around the IPA command. It's safer. So if I check my network card, just ignore the loop back. It's for a different conversation. This is my network card, and I can find here my MAC address, and it's now a 000C29. If I go back to this, I can just type here on this place 000C29. Whoops, I just hit every single keyboard combination. Funny enough, let me check this out. Since these are both running on VMware 000C29, yeah, they are the same vendor ID 000C29. This just confirms that that identifies the vendor. So you probably, if you are testing this with me on also VMware machines, you'll see that your vendor is probably the same, because again, this just proves my point. This number, identifies the vendor, and not one vendor has one ID. So Cisco have plenty of IDs, VMware have plenty of IDs. But if you go back here, even though they share the same vendor ID, so you see this is 95ACF1. See there, 95ACF1. If I go to the Windows, it's different. So they share the same vendor ID, but each PC has its unique identification for its network card, exactly like I just explained to you here. Okay. So as a quick summary, so MAC addresses are used to identify devices on the local network. They behave similarly in Wi-Fi and cable networks. Wi-Fi is slightly different, but that's for another video. So it's when you connect to two or more PCs on the network using a hub or switch or something similar. Each PC will have, when I say PC, it can be printers or anything that shares the same Ethernet connection. So each PC is going to have its own MAC address, which is like its unique name on the network. It's only valid on the local network. It's not valid, for example, when you go to the internet, that MAC address will just get dissipated on your local network. So the MAC addresses are used on your local network, so PCs can identify themselves with one another. Okay. This number, it's built in on network cards. It's burned in from factory on your network card. You don't have to configure it. It's done on the factory. Okay. And these are used to identify each host on the local network. I have shown also the IP config/all and the IPA commands on Windows and Linux, so you can find out your MAC addresses, and you can know what your MAC address is. And I also shown you the OUI website, where you can use the first half, in simple terms, the first half of the number, so you can find out who the vendor is. The second half, it's unique to your PC. So use the comment box to ask me questions. Feel free to ask all the questions you want within this subject. I will make more videos about this, because this is just a small sample of a bigger subject, a bigger topic. Okay, so this is the starting point. So now you know what the MAC address is. In the future, I will make videos about how the Ethernet frame looks like, how this correlates with IP addresses, what is the ARP protocol, etc., etc., etc. Ask any questions in the comment box below. Feel free to ask me any question. Like and subscribe. It really helps the channel. But if you cannot or don't want to, it's also fine. And I'll see you in the next one.